Hey guys, I'm Andre and this is a video that I'm recording for my physics class. I'm going to be explaining to you guys how to apply the momentum principle. And to do that, I'm going to give an example of a problem that was on my test, which I actually got wrong. So I'm going to explain how to solve the problem and hopefully both me and you learn something from this experience. So I'm going to switch over to my desktop and I'm going to show you guys the problem. I'm going to read it, and then we're going to go through how to apply the momentum principle and use it to solve the problem. So here we go. Hello again, YouTube. I'm back, and we're going to get started, and I'm going to explain to you guys how to go about actually solving this problem. So here we go. There's going to be a bunch of, there's an outline that I made, and it's going to contain all the steps that we need to do in order to solve this problem. So in order to calculate the magnitude of the momentum, we're going to need to first know our momentum formula, which is gamma times mass times the magnitude of velocity. Now, gamma is a quantity which allows us to calculate the momentum of particles that are moving at very fast speeds, like electrons, and it has a formula which is 1 over the square root of 1 minus the magnitude of velocity over c, which is the speed of light, and we're going to take that quantity and we're going to square it. So this affects how we're going to actually go about solving the entire problem, because we realize that the magnitude of velocity is a very important quantity as it's used in multiple places in this problem. So let's get started and actually calculate the magnitude of the velocity. A couple notes about that before we do it, though, is that calculating the magnitude of a vector results in a scalar quantity, and in order to find the magnitude of a vector, we need to use the formula for the magnitude, which I'm going to show you guys right here below. So the magnitude is the square root of your first quantity. We're going to call that one x, and you're going to take that quantity and you're going to square it, plus your second quantity, we'll call it y. We're going to square that one as well, and then your third quantity, which is z, and we're going to square that one as well. So, this can continue going on. If you have more than 3 components, you just square them and continue adding them all together. So let's take this formula and let's plug in the values that we were given for our initial velocity. So in the x direction, we have the quantity 0.8 c, which receives the speed of light. Quantity in the y direction is 0.5 c, and your quantity in the z direction is 0. So we have this formula right here, and I'm gonna evaluate that in a minute in a Python shell, so I can show you guys a little programming too, which would be pretty exciting. Next up, we're going to calculate gamma. So we have this velocity, the magnitude of the velocity, and we're gonna use this value, and we're gonna plug it into here. So if we scroll up, we'll see our formula from before is 1 over the square root of 1 minus the magnitude of the velocity over c, which is your speed of light, squared. So let's take that formula, let's move it down here, and we're going to substitute in our values that we have. Alright, so I just had some basic syntax errors in my program, so I fixed them, and now we're actually able to calculate a value for gamma. So here's our formula again. Gamma equals 1 over the square root, which is done by a command called math.square root. I was missing the math module, which is why it wasn't working for me. The square root of 1 minus the magnitude of velocity. Note that you could also take this number and just type Vmag, and so we can take the magnitude of velocity and divide it by the speed of light. So that's c. You can also put a c there and then retick it and raise it to the second power. So I was also missing my exponent there. But now we have gamma, we fixed it all, so let's run this program real quick. So I run it, and we see that gamma is 3.015. Okay, So now that we have the magnitude of our velocity and we have gamma, we are pretty much all set to finish solving this problem. So we're gonna put it all together, and we're just gonna calculate the final quantity for our momentum. So remember that momentum is gamma times mass times velocity. Let's just move it down here, and since we already have our Vmag and gamma, I'll just put them all together. So let's put it back in our VPython. Here it is. Momentum is gamma times mass times velocity. We have gamma here, and we need to put in the mass of the electron. So if we recall from earlier, the mass of an electron is 9 times 10 to the negative 31. So there'll be 9e to the negative 31 for VPython. I'm going to put it right up here. So momentum is going to be equal to gamma times m electron times Vmag. And remember, this is the magnitude of the momentum, so I'll put mag in front of it for better naming. So there's your final quantity. Let us print it out real quick. And we have the final answer of 7.68 times 10 to the negative 22. Alright, so we have now solved part 1 of the question. Here's the solution that I was given from the test, and it's basically the same thing that we just did, and it contains everything. So I'm going to come back and we're going to work on continuing on with this problem and doing part 2. Back, so I just had to pull up a quick Python shell and whip together a little program for us so that we can get started and actually evaluate all these quantities. So here's my simple program. I first defined some constants that we needed. So we have c, which is 3e to the 8, and then your initial velocity, which is a vector, which is 0.8c, 0.5c, and 0, which is what we were given. So I'm using something called VPython, and it allows you to easily do vector operations and evaluate things like the magnitude. So from a formula here, that's right here. So we have magnitude of velocity square root of 0.8c squared plus 0.5c squared plus 0 squared. I just basically took that and we're gonna, there's a command that we use in VPython, it's called .mag. So I just typed vmag equals initial velocity .mag, and we're able to get a quantity for that. And I'm gonna just print that out real quick for you guys so you can see what the actual quantity evaluates to. So let's run the program, and you see that vmag is this number right here, pretty large number. So I'm gonna copy that real quick and put it back in our text document that we're working out of here. And now we're going to calculate gamma. So we're going to just simply substitute the stuff that we have here. So remember, this was the magnitude of velocity over c squared. So this is going to look like this. So there's the magnitude of velocity that we calculated before. So it's going to be right here. And then it's going to be divided by 3e to the 8, which is your speed of light, and we're going to take that quantity and square it. So let's go back to VPython real quick, and we'll run this, and we'll get our value for gamma, and then we will, after that, we'll just put it all together and get our final answer. So if we just copy this line right here, I can get the equation that I need. And we'll call it gamma. So I put in the number here. Note that we could also do cool things like just typing in Vmag here, since we made a variable for it. And 3e to the 8th is also the same as just having the speed of light. And we made a constant for it, so it's just c. So the thing about Python is in order to square things, you need to add 2 asterisks and allow you to square it. So now let's print out the value of gamma. Print gamma. And we have gamma. So here we go, let's run the program. Oh, invalid syntax. What is up here? So it's probably something with my exponents right here.